This is the study of inequalities. You have learned this since elementary school, maybe first grade, I believe, like less than and greater than symbols. So there are keywords like less than, fewer than, and below. They all mean the same thing. Those are numbers that are going to be less than 10. So this is a number line. In this number line, we find 10. We draw something called an open dot because it cannot be 10, but it can be all the numbers, all the rational numbers that are less than 10, such as 8, 8.5, 9, 9.5, 9.9, but not 10 because it has to be below, less than, or fewer than 10. Less than or equal to, at most, no more than, maxima is not greater than, all means the same thing. It means it can be 10, so we draw a closed dot, but it has to be less than that. So the maximum could be 10. Can't be more than 10. The maximum could be 10, 9, 8. Then we have more than, greater than, above, exceeds. So that means it has to be above 10, such as 10.5, 11, 11.5, and 12. But it cannot be 10 because it has to be more than, greater than, exceeds 10. It's an open dot. And then more than or equal to, at least, no less than, minimum. So that means it can be at least 10. I mean, 10 could be the least it could be, but then it could be 11 and 12. So that's why we draw a closed dot. So now let's practice some one-step inequalities. So what I like telling the kids to do is I like telling the kids, I would like you to circle the inequality. So cover with your finger or hand, cover the X. This is the variable. How do I undo addition 4? Subtract 4 on both sides. It's canceled. X is less than -9, -4 is -13. Then we draw a number line, -13. What's closer to 0? -12, -11. And what's farther from 0? -14, -15. Is this going to be an open dot or closed dot? X is less than. So less than, where do you find the least to greatest? The least side is down here. So it has to be less than -13. So you shade this side. Cannot be -13. It has to be less than -13, like -14, -15, -16. Let's try this one right here. So I circle the inequality. I cover up the variable x. How do I undo a multiplication? I divide both sides by 3. So x is less than or equal to -8. So same thing, I draw -8, -7, -6, -9, -10. Because it can be less than or equal to -8, I draw a closed dot and I shade in everything that are less than. Let's try one last one. Let's try this one. I underline this. This is x. How do I undo a divide by? I multiply 5 times 5, multiply by 5, cancel. X is greater, equal to 35, because a negative times a negative is positive. So this is 35, 36, 34. It has to be a closed dot because it has to be greater, equal to, so like that one. To check your answer, you can actually input it back into it. For example, if I took 40, 40 divided by 5 is 8. Is 8 greater or equal to -7? It is. If I did 35, 35, wait, stop. And you go redo this one. I just realized this is a multiplication dot. My handwriting is not good. So the answer is actually -35. So that's how I knew I did it wrong, because I said 40. 40 divided by 5 is 8. But also 35 divided by 5 is 7, which is greater. But there's actually more numbers than that. So let me redo this completely. That's why it's good to do something called a test point to check your answer out. -7 times 5 is -35. So you have -35, -34, and -36. It is going to be a closed dot greater or equal to. So it needs to be on this side. So you're going to the greater side. Remember, a number line goes from least to greater. So let's use our test points. -35 divided by 5 is -7, which is greater or equal to -7. We do try -30. -30 divided by 5 is -6, which is greater than -7. So it works.